Have you ever wondered if the most iconic weapon in science fiction could actually exist in the real world? The lightsaber is instantly recognizable, a blade of pure energy that cuts through almost anything. But when you break down the physics, things get really interesting and really complicated. Let's start with what a lightsaber blade would actually need to be. In the movies, it behaves like a solid rod of light. But light doesn't just stop at a fixed point in midair. A laser would shoot straight through whatever is in front of it and keep going forever. So a blade of light is out. What scientists believe would come closest is superheated plasma. Plasma is the fourth state of matter. When you heat a gas to extreme temperatures, its atoms lose their electrons and you get this blazing, electrically charged soup. Think of the surface of the sun or a bolt of lightning. That is plasma in action, and it absolutely can cut through metal and other solid materials. So the blade itself is theoretically possible. The real nightmare begins when you ask how you would contain it. Plasma doesn't just sit still in a neat column. It expands, it dissipates, it wants to go everywhere at once. To hold it in a blade shape roughly a meter long, you would need an incredibly powerful magnetic field. This is called magnetic confinement, and we actually use a version of it right now in experimental fusion reactors like tokamaks. These machines use massive superconducting magnets to trap plasma in a donut shape, so it can reach temperatures hot enough for nuclear fusion. The key difference is that a tokamak fills an entire building. Shrinking that technology down to fit in the handle of a sword is so far beyond our current engineering that it borders on impossible with anything we know today. Now, let's talk about energy, because this is where it gets truly absurd. To maintain a blade of plasma at tens of thousands of degrees, you would need a power source that puts out an enormous amount of energy continuously. Some physicists have estimated that sustaining a plasma blade for even a few minutes would require something on the order of megawatts of power. For reference, a megawatt can power hundreds of homes. The energy density you would need in a handheld device doesn't exist in any battery technology we have. You would essentially need a miniature nuclear reactor or some exotic power source we haven't invented yet, sitting right there in the hilt of the weapon. There is another massive problem people tend to overlook. Even if you solve the plasma and the magnets and the power source, the heat alone would be a deal breaker. A blade that hot would radiate so much thermal energy that it would severely burn the person holding it and probably set everything nearby on fire. You would need some kind of perfect thermal shielding that also fits inside a small handle, and that kind of material doesn't exist either. Some engineers and YouTubers have built devices they call real lightsabers using compressed gases and high temperature flames, and these are genuinely impressive. They can reach over 2,000 degrees and cut through steel, but they require external fuel tanks. They don't have a fixed blade length, and they certainly don't clash against each other the way lightsabers do in the films. That last part, two plasma blades locking together in a duel, would require both blades to generate magnetic fields that repel each other on contact. It is theoretically conceivable, but adds yet another layer of engineering that we have no idea how to achieve at this scale. So, could a lightsaber actually work? The individual pieces of the puzzle exist in some form. We can make plasma, we can confine it with magnets, we understand the physics, but combining all of it into a portable, handheld, safe weapon is so far from our current capabilities that it remains firmly in the realm of science fiction.